Welcome to my ACI course, and right now we're kind of just going to get started with an introduction to ACI. I'm going to do my best introduction to a technology slash product as I can without being too markety, but at the same time, honestly, some of that marketing kind of speak is needed so that you guys really understand where ACI fits into our networks, because as network engineers, a lot of us were really used to just doing stuff the traditional way. You know, we would shoot into the command line of a switch and we'd, conf T enable, depending if you're Nexus or iOS, and we just start blasting away at the config. And we've been doing stuff for 15 to 20 years, almost the exact same way. Some new technologies have come about, Fabric Path. We had, it was kind of Cisco's interpretation of Trill. We had OTV. Those have kind of changed our way of looking at networking, and ACI kind of flips everything on its head. So ACI is unlike anything you guys have done, or girls, politically correct, right, have done up to this point. And honestly, it's a little bit hard to wrap your head around the first time. So if this is your first real dive into ACI, don't be afraid to raise your hand, take a step back and say, wait a second, I don't understand what the hell he just said, because it's necessary, right? You have to question what you're seeing. And I went through the same thing when I first saw ACI. The first couple times I went through ACI and I tried to learn the gist of it and what we were trying to do with it, I'm gonna be honest with you guys, I hated it. I was like, I can do the same thing in the command line in 2 minutes. I can set up OSPF in 2 to 3 minutes between two routers, including interface configs, changing the network, OSPF network type, etc. We can get in there and we can do that pretty fast. Well, things like that within ACI are a little bit more difficult and a little bit more timely to implement when you're doing everything the traditional way through the GUI. Now, this course isn't aimed to make you, super duper ACI expert man by the end of it, because we're really going to concentrate on what is ACI at the basic level. How do we set up policies in ACI? How do we do layer 3 routing in ACI? How do we do, extending layer 2 out of the ACI fabric? We're going to get into that stuff. What we're not going to get into is things like service chaining, scripting, any of that really advanced stuff, because I'm of the mindset, a lot of the classes that I took for ACI, including some Cisco learning classes, we really spent a lot of time on products. Then we came in and we blasted through some of the policy stuff really fast. And then at the end, they really dive you into a lot of the service chaining stuff, a lot of the scripting components, which, don't get me wrong, are very important. But for me, at least, I was like, whoa, can we take a step back and just get ACI working at a very basic level? And then maybe later we can come back and learn how to automate that process, learn how to make it a little bit more quick, a little bit more efficient. Because again, a lot of the times when you have to point and click your way through here, some of the stuff like setting up routing is going to take you, 30 minutes. When you do get a firm understanding of that, though, you're going to be able to use things. There's a lot of terms thrown out, DevOps. You're going to be able to use things, though, like scripting engines. You're going to be able to use products like Chef to automate these tasks. And what may take us 30 minutes to click through is going to take us 30 seconds once we have it, wrote within one of those other platforms, and they're just going to run a script to configure that all. So again, this course isn't aimed at that. We're really aimed at what is ACI? How do we configure ACI? What are the components of ACI? And if you're going for your CCIE, Data Center version 2 exam, this is going to be a great course to teach you everything that you need to know in terms of what you're going to be tested on from an ACI perspective within that exam. So without further ado, let's get started with this thing. So I'm going to zoom in here so you guys don't have to look at my ugly mug the whole time. So ACI, again, and this is part of my marketing propaganda, ACI is kind of what they refer to as a policy-based framework, meaning we're going to abstract a lot of the things that we may be used to, and we're going to be able to write policy around rather than a subnet or a VLAN. We're going to be able to write it around what's known as an endpoint group. So we're changing the way we look at networking and how traffic flows through the network, because now it's all going to be based on some common policies that we write from within the ACI controller, okay, which we're going to learn is called the APIC. Now, this is really kind of prevalent, they say, across 3 domains, and those domains being application, networking, and security. So why they kind of hone in on those 3 domains is because we're going to be able to do stuff like filter traffic. So where we say security down here, we're going to be able to apply things like ACLs. Application is more geared towards, how can we optimize the application? Because now we're going to be writing on what we kind of refer to as a 10, 40, or even 100 gigabit per second infrastructure. So we've got blazing fast speeds, but we're still going to need to do things like optimization of the applications. And we're going to be able to do that using a lot of the service-based chaining that we're able to do through ACI. And then furthermore, networking and security, we can do IPS, IDS functionality. We can do, VXLAN overlays, which is a big part of ACI. So we're going to be able to write a lot of different policy within ACI. And the benefit of having policies is that a lot of these are going to be reusable objects. So it's not something that we have to go in there. Imagine if you had a network with 500 routers. Well, you got to go in there 500 times and write those damn QoS policies, and you have to write those ACLs. Well, not anymore, guys, not anymore. With ACI, you're going to write that one time basically on these APIC controllers, and you're going to be able to push that out based on policy. Where is it needed? Oh, it's needed on this leaf switch. Okay, the APIC's going to know that. It's going to push it out there for you. So we no longer are going to have those kind of mundane tasks. And I tell a lot of people, because a lot of people come into ACI and they're very quickly overwhelmed with the amount of kind of configuration that you have to do at the front end. Well, whereas a common network, you typically start off, from, I'm trying to think of, let's make this time, make this line time, and this will be, our work. So usually with a traditional network, this is kind of going to go up over time. Well, with ACI, we're going to start off pretty big, like in the amount of work that we're going to need to do with ACI. But once you get it implemented, that work's going to drop off and kind of just plateau like this. And I think Cisco actually has some graphs out there that represent something like this. But this has been historically my experience with it, is you're going to have a lot of work at the very, very beginning, but after you get that work done, it's kind of going to just plateau off, and you're just going to be able to reuse stuff that you've already done or that you completed near the beginning of that implementation. So just be aware of that as you go into it, because I don't want you guys to get soured on it, kind of like I was in the very beginning. Now, what is policy? You're going to hear this word thrown out a lot. And again, if Cisco has kind of pitched this to you, if you've watched any Cisco Live presentations, what is policy? Well, I looked up policy specifically in the Merriam-Webster dictionary, and I found one. It was a definition for kids. And they said a policy is a set of guidelines or rules that determine a course of action. So a set of guidelines or rules. And part of what struck me in the beginning was Cisco, in some of their Cisco Live presentations, they were like, what is a policy? Well, think of a no parking sign. Is that a policy? That no parking sign, yeah, is absolutely a policy. They're telling you when you see that no parking sign that, hey, you cannot park here, right? So how that's fine, that's a policy. How do we enforce that policy? And we're going to find that enforcement of these policies, at least within ACI, is going to be done through the use of what we call contracts. And we'll get more into those kind of as we go on, right? The no parking policy, who enforces those? Well, usually it's one of those toll people or one of those roving police officers that's going to go around, and if you're parked in a no parking spot, they're going to go through there and probably give you a ticket. Okay, so that is what policy is in my mind. Now, policy within a network may be a little bit different. We could have a policy, and I've got an example up here, traffic going from one web server to this host must pass through a firewall. And I want you guys to think of things like, again, quality of service, security, service level agreements, because when we start looking at these different policies, this is going to be like, how do we mark this traffic, right? Think of quality of service. How much bandwidth do we want to give to this particular endpoint group? Okay, how do we want to queue that traffic? Do we want to send stuff through an IPS IDS sensor? Okay, we may have a tipping point sensor sitting out there. Do we want to redirect a certain flow of traffic? Do we want to forward, redirect, or even maybe drop frames based on a firewall policy, maybe based on an access control list, or what they refer to within ACI as a filter? Right, within a contract. We could also send stuff off for server load balancing, so we could, again, this is part of the application optimization that we may be dealing with. We could redirect traffic again through the service chaining capabilities within ACI to basically say, oh, you're going to this server, well, we're going to send this specific flow of traffic because it's a www-based traffic going to this particular server. We're going to send you off to a load balancer. Okay, and we do have that capability again within ACI. Now, we've been looking at the network, the same way for many, many years. And, typically, if you think about a traditional data center, right, we have two things, okay? We have our VLANs and we have our subnets. And typically, these two are tied together. We're always, and again, this is usually on a one-to-one basis, we're going to have a single VLAN that is tied to a particular IP subnet. Am I wrong? A common example, right? We may have 10.10.10.0/24 tied to VLAN 20. And again, within that data center, usually that's on a one-to-one basis, unless you have like that wacky guy with the crazy eyes who like to do stuff his way, and maybe he tied two subnets to a VLAN. Yeah, I don't know. It's possible, right? You can do it, but a VLAN is typically what we called a broadcast domain. And those lines have been blurred over the years, right? Because that was supposed to be two completely separate things, right? A VLAN was supposed to be strictly a layer 2 broadcast domain. A subnet was supposed to be a layer 3 construct that we used to forward traffic, right? We would route based on IP prefix. That was how we delivered those frames or those packets. So those lines have been blurred though over the years, because what we've done is we've said, hey, we're always going to have this VLAN. It's always going to be tied to this subnet. And if you think about your networks, guys, think about how you address traffic. Well, when we go in here, we're going to see that a VLAN is again typically our subnet boundary, and then that VLAN interface, or that layer 3, whether it's an SVI, whether that's a routed port for that subnet, is going to be where we apply our policy. So, this is going to be, and again, I don't want to generalize too many things in this class, but what we would typically do is we'd say, if this was our VLAN 20 and our subnet here, and I totally screwed that up, didn't I? I put the IP prefix in the VLAN box, and I put the VLAN number in the subnet box. I think you guys get what I mean, though. But typically, that was going to be how we organize stuff. And I worked for a lot of different, Fortune 50, 100, 500 enterprises, where they would come in and say, what, this tuple, this subnet and VLAN combination, this is going to be, our web servers. Okay, or maybe another one, we could have VLAN 10 tied to 10.10.20 0/24. This is going to be our database servers. And it was like, you have to have some sort of IPAM, right, to keep track of IP addresses within those guys. But by God, if you had a new web or database server, they better be in the correct VLAN and the correct prefix, right? Am I right? I mean, that's typically how it's done, because what did we use that for? We use that as kind of our security domain, right? We use that as that point in our network where we applied that policy, right? This is, we'd have some quality of service policy map marking traffic based on that layer 3 boundary. We would have some kind of ACL, some kind of filtering there. And by God, that's where we did our filtering. Okay, if we had some sort of server optimization or server load balancing, that again was typically that point where we said, okay, hey, we need to apply this policy because we're coming in this interface. And that guy's just, if you think about it, it doesn't scale real well. It doesn't, because as we move on to this next slide, what you guys are going to see is, I got our traffic cop here saying, hey, stop, go to the firewall, go to the load balancer, because that was that point in the network where we did that sort of thing. But if you think about it, I want you guys to really think hard. We've got this server out here, and he's got, a static IP address, 192.168.110/24. This could be a web server, database server. I don't know what the hell this little orange cylinder looking thing is. Maybe it's disks. I don't know. But think about what happens is this guy is tied through usually a layer 2 network like a VLAN, right? To ultimately his layer 3 boundary, his first hop router. That's how he gets out of his subnet. Okay, so typically we'd have some sort of IP address up here, depending on what if his gateway might be .1. So we'd say that router was going to have a .1 interface. Well, what happens is at this router, or at this specific point in the net, did I just say Pacific? That's an ocean, not a word. All right, specific point in the network, this is where we would come in and we'd do our marking. So we'd have our our quality of service policy map, we'd have our class maps defined. This is where we'd give it this preferential queuing. If it was voice traffic, maybe we stick it in a low latency queue. We'd give it a certain percentage of the bandwidth if it was a very, very important server or a very, very important server farm. We'd also come in here and do our security and our application network services, right? So we'd do our ACLs, our ACEs. We'd send stuff off to a firewall. We'd copy traffic, to an IPS IDS sensor, so on and so forth. I think you guys get the point. This was our boundary, right? So we'd flow traffic through all our policies, and then we pass it off to our happy little cloud here. So happy little cloud, right? Not a tree. We'd have our happy little cloud, whether this is a WAN, a MAN, whatever, right? Wherever he was going. That's the process that we went through. So this was all fine and dandy. Again, we've been running like this for years, people. Years. So what happens if all of a sudden we come in though, and for some reason through acquisition, we need to change that guy's IP address, right? Because previously we were classifying that guy, right, either based on the IP or based on this VLAN that he was riding on, but all of a sudden they both changed, okay? What happens to this policy in this specific case, it's gone. Right? We either have to redo it, we have to copy it. There's some sort of manual intervention that we need to go in there and do. And again, this has worked fine for years. I know a lot of places that still do it this way, right? This is what we're trying to change with ACI. Okay, this is what we're trying to change. And you have to change your mindset a little bit in order for this to make sense. So as we move on, what if there was a different way? What if there was a different way to approach networking? And rather than classifying based on these common layer 2, layer 3 constructs that we've been using for years and years and years, what if we could classify them some other way? And that's, again, this is part of what ACI does. So again, imagine we had all these servers, and these servers got those stupid bronze cylinders, right? I don't know why they have the bronze cylinders, but they have the bronze cylinders. But again, we've got a couple in different subnets. We've got 10, 10, 10, 10, 20, 20, 20, 20, 30, 30, 30, 30, and 30, 30, 30, 31. So imagine all these are /24s. These two guys here, they're of course in the same subnet. So again, they're within the same layer 2 domain. They're probably, hopefully, if they're in the same data center, in the same VLAN, right? Because we tie those together. So what if there was a different way to classify these guys? Instead of the VLAN, instead of the subnet, what if we could create these containers out here, which we're going to learn within ACI are called endpoint groups, or EPGs, okay? What if we could take these guys, and again, rather than classifying on the old constructs, we could place these guys into these containers. And again, at this point, as we move these guys into their containers, their IP addresses do not matter, right? We're still gonna be using IP addresses for forwarding, right? Just not technically within the fabric. Okay, but if you have a typical or a traditional layer 2 or layer 3 domain tied to your ACI fabric, of course, when we're going out to, this server over here, of course, we're still going to be pointed to that IP address. But within ACI, we're no longer classifying or applying policy based on that IP address. We're going to apply policy based on these endpoint groups that we've placed these guys within. Okay, so we have a user group, a web group, and a database backend group. So look at this. Take a good hard look at what we're doing here. We've got, these two guys, they're in separate subnets, right? And they're in the same EPG. We've got 30-30-30-30 and 30-30-30-31 who are in the same IP subnet. Okay, they're in the same IP subnet, but they're in different endpoint groups. So what does this allow us to do? Rather than using that VLAN or that IP subnet to apply policy, now we're going to be able to write what we call contracts within ACI. Okay, and basically our policies are contained therein, and we're going to be able to use this provider and consumer relationship that ACI uses to basically dictate, hey, the web server is providing this contract. Okay, so if we're going from, actually, yeah, I've got the web server providing a contract. So the web server may be providing a contract that the web may be providing a contract that the users consume. Okay, so if a user wants to go to that web server, as they come in through this contract, if we have specific QoS, filtering policies, or even application, optimization stuff like server load balancing, we have to flow through these policies before we get to go to that web server. Okay, so no longer does it matter the IP address that we're coming from or we're going to. Okay, based on the endpoint group that we're in, that specific policy is going to be applied. And you guys can kind of hopefully start to see the benefit of this. Okay, because as we come in and say we just bring in new web servers and they're going to have the exact same rules applied to them as this web server, all we have to do is stick that guy within that endpoint group. Again, he doesn't have to be in the same subnet. He doesn't have to be in the same VLAN. Right? He could be, this guy could be 100.100.100.100. The IP address doesn't matter at this point. Okay? The IP address does not matter in terms of the policy being applied. It's the endpoint group that the policy is actually applied to. So again, it's kind of a mind meld, right, for you Trekkie fans. We have to change the way that we think a little bit. And even if it's still fuzzy right now, guys, I promise as we get into these demos and stuff, a lot of this is going to become a lot clearer as we actually get in and we start to see some of this working.